10. From our previous class, I told you that when we are told to find the derivative of a function that look like this, log u base a, the derivative of y is equals to derivative of u all over u ln a. You understand? So we are going to use the same step. We are going to use the same approach in this place to find the first derivative of y before we proceed to the second derivative. Okay, let us proceed. Derivative of y is equals to derivative of u. If you compare this function with this function, you can see that u is what? X. So I'm going to take the derivative of x. What is the derivative of x? Yeah, the derivative of x is 1. So I'm going to have 1 all over the u. U is what? X. So I'm going to have x ln a. A is what? The base, and the base is 10. So I'm going to have ln 10. So the first derivative of y is 1 over x ln 10. Now let us proceed to take the second derivative of y. In order to find the second derivative of y, which rule are we going to employ to differentiate this function? Yeah, we are going to employ the quotient rule. Why? Because we have a function that is in quotient form. We have a function that is dividing themselves. You understand? So from quotient rule, we can represent this as what? U, and this as what? V. Now, from the quotient rule, when we are given a function that looks like this, y is equals to u over v. The derivative of y is equals to what? V multiplied by derivative of u minus u multiplied by derivative of v all over v squared. So we are going to use the same approach here. The second derivative of y is equals to v. V is what? X ln 10. So I'm going to have x ln 10 multiplied by the derivative of u. If you differentiate 1, you are going to get 0, because 1 is a constant. In differential calculus, when we differentiate a constant, we are going to get 0. So this will multiply by 0 minus, open another bracket, u. U is what? 1. 1 multiplied by the derivative of v. Now I want to pay attention here. V is what? V is equals to x ln 10. I need the derivative of v. The reason why I extract this out is that I want to explain, I want to take the derivative of v. Are you getting it? Because I need it in this formula. So let us take the derivative of v. If you want to differentiate v, which rule are you going to employ? Yeah, we are going to employ product rule. You see, one thing about differential calculus is that you might be given a question and you are asked to differentiate such question. You can have a question in which you are going to employ various rules. For example, now look, we are dealing with logarithmic differentiation. However, we are still making use of what? Product rule. Are you getting it? So let us use product rule to differentiate this function. According to product rule, the derivative of v is equals to differentiate a part, keep another part constant, then add the same part, differentiate another part. So differentiate x. I'm going to have 1. Keep ln 10 constant. So I'm going to have 1 multiplied by ln 10 plus, then differentiate ln 10 and keep x constant. So I'm going to have x multiplied by, if you differentiate ln 10, you are going to have 1 over 10. If you differentiate ln 10, you are going to have 1 over 10 multiplied by 0. So this will be what? 0. So for this, I'm going to have x multiplied by what? 0. You understand? So derivative of v is equals to what? 1 multiplied by ln 10. That is ln 10. So the derivative of v is ln 10. Please, hope you understand how I got this. I make use of the product rule of differential calculus. When we are given a function that has 2 parts, we are going to use product rule. So I make use of the product rule. This is one part and this is another part. I differentiate x and keep ln 10 constant, plus then I keep x constant and differentiate ln 10. Are you getting it? So I got ln 10 as my derivative of v. So that will be 1 multiplied by ln 10. So let's proceed. The second derivative of y is equals to, all over v squared. That will be what? X ln 10 squared. So let's proceed. X ln 10 multiplied by 0, that is what? 0. So 1 multiplied by ln 10, that is minus ln 10. So I'm going to have minus ln 10 all over x ln 10 squared. Do you understand? So let's proceed. The second derivative of y is equals to minus ln 10 all over x squared ln s squared ln 10 squared. You understand? So you can proceed like this. The second derivative of y is equals to this ln 10 we cancel one ln 10 here. So I'm gonna be left with minus 1 all over x squared ln 10. So the second derivative of y is equals to log x base 10 is minus 1 all over x squared ln 10.